Hello and welcome to the second part of lesson number 6 in Unit 0 of our Grade 10 academic math class. This is Expanding Polynomials and the Distributive Property, Part 2. So when we started this video, we had a question where we worked on expanding two sets of binomials and subtracting the second expansion from the first. I explained some of the pitfalls that might happen. Same thing for the second example, except that it was the second binomial was written as a single binomial squared. I encouraged you to do a rewrite and then work it out, minding the same pitfalls as the first question. Third example was just multiplying a binomial by a trinomial, just more terms but the same idea. Last example we're going to tackle here before we get to sort of a more practical application is multiplying out three binomials. So as you can imagine, I'm not going to recommend you try to do all three at the same time. That's a surefire way to get lost or confused. I would definitely recommend that we partition off using a set of artificially inserted square brackets. We tackle one set of binomials first, and then we move on and expand that first binomial into the result. Let's give that a try. So we have just a rewrite on our first binomial here, 2x minus 4, and now square bracket. We're going to just expand these guys out. So same principle as we've been doing the last couple of lessons. X times 2x, x times 6, negative 4 times 2x, negative 4 times 6. So let's get that math done. X times 2x is 2x squared. X times 6 is plus 6x. Negative 4 times 2x is negative 8x, and negative 4 times positive 6 is minus 24. And now we are going to simplify the contents of that newly expanded binomial, or set of binomials. Here are the two terms that are alike, 2x squared, and we have plus 6x minus 8x, that's minus 2x, minus 24. Now students will sometimes ask if they can distribute the 2x minus 4, our first binomial, into the unsimplified version of the binomial expansion we did at the end. The answer is yes. It's just that, again, I think there are more opportunities for you to make errors if there's more terms for you to multiply together. The simplifying, I think, is a more straightforward step. And just a little bit easier to manage your output with fewer mistakes. But again, technically you don't have to do that. It's just kind of a good practice, I guess. All right, so we have expanded our second set, or the second two binomials, simplified them, and now we are going to distribute that first binomial into them. We have 2x times 2x squared, 2x times minus 2x, and 2x times negative 24. Let's get that one done first. So 2x times 2x squared is 4x cubed. 2x times minus 2x is minus 4x squared. And 2x times minus 24 is going to be minus 48x. And now we head to the second half of this, the second term in the first binomial multiplied by the whole output. So minus 4 times 2x squared, minus 4 times minus 2x, and minus 4 times minus 24. Let's grab that. So we have minus 4 times 2x squared, that's minus 8x squared. Minus 4 times minus 2x is positive 8x. And lastly, minus 4 times minus 24 is going to be a positive 96. All right, a lot of terms in this one. Again, now we're just gathering together the terms that are alike. 4x cubed is the only one that's like that in terms of it being cubed, so we'll rewrite that. Next down the line, we have minus 4x squared, and there's a minus 8x squared. That will give us minus 12x squared. Next, we have minus 48x and plus 8x. That will give us minus 40x, and there's that plus 96, all alone at the end. So there you have it. Again, the takeaway I want from this one for you is that you should do one set of the binomials first. I prefer the second ones again. What happens when you expand with the first two binomials is that sometimes people forget to put those big square brackets back in, and you end up with an incomplete distribution. But again, technically nothing wrong with that. Okay, so this is the practical stuff. Let's head on to an example where we're going to be working with an actual shape. We're being asked to calculate the area and perimeter of this shape. So let's start with, let me just clean this up a little bit. I left some markings on it from the previous lesson. There we go. Let's tidy that up. So what we have here is a compound sort of rectangle we have been tasked with finding the area and the perimeter. So let's start with the perimeter. Now, as we know, the perimeter is basically adding up all the sides of this shape. What you'll notice is that there are two sides that are missing. So I've labeled them here in the picture, side 1 and side 2. So let's start with side number 1. Now, side number 1 is, as you can see by my highlighting, it's actually a combination of this side right here, the x plus 2y, and this side here, x plus y, combined together. So let's do that combining. It's x plus 2y plus x plus y. Now again, if I want to be really strict about this, I'm going to make sure that I put brackets around those guys because I am adding the entirety of the value of that side. Now again, when you're adding, it's not such a big deal because none of the signs are going to change by distributing a negative, but let's do a rewrite anyway. X plus 2y plus x plus y. And now we gather together the terms that are alike. So we have 2 x's kicking around and we have 3 y's. So the value for side 1 is 2x plus 3y. We need to do the same thing for side number 2. Now side number 2, just checking my spacing here, got lots of it. So side number 2 is again a combination of a couple of sides that we do have values for. And as you can see by my highlighting, it's a combination of x minus y and 2x plus y. So let's combine those as well. So we have x minus y and being added to 2x plus y. Again, I'm going to do a rewrite step here. If we were subtracting them, that would be a little bit of a different story. Here it's mostly just for form. And now we are going to combine the ones that are alike. And x and 2x's is 3x's. And minus y plus y is no y's at all. So this side over here is now can be written as 3x. So this helps us out. We are now going to just put together all of the sides of this shape to get our perimeter. So the perimeter then will be equal to, so let's start with side number 2 because I can see it the way I've got my screen. That's going to be a 3x. The side beside that, let's get some brackets in here, is 2x plus 3y. Then we've got that little side on top, that's 2x plus y plus 2x plus y. And then the one on the side plus x plus y plus, did I just do that? Nope. And then we got the one that goes horizontal, so x minus y. And then last but not least, that last vertical side, which is x plus 2y. X plus 2y. All right, so again, I'm going to skip the rewrite step just for time here. Essentially, the next step is just, all of the brackets have dropped out. So I'm going to gather together now the terms that are alike. So let's start with the x's. We've got 3 x's, that's 2 x's, so that's 5 x's, 7 x's, 8 x's, 9 x's, 10 x's. So we have perimeter being equal to 10 x's. And let's go through and figure the y's now. So we have 3y, another one is 4y, 5y, taking one away, so back to 4y, and then another 2y is 6y. So plus 6y. So there we go. We have an expression for the perimeter. Put a little box around that since that is technically the answer that we're looking for. So that's how you would do perimeter. Make sure that you combine the sides that will ultimately create the side that you're missing, and then add up every side to make your perimeter. That's the first part. Second part is the area, and this one's a little bit more tricky. So what I want you to consider by looking at this shape is that there are actually sort of 2 different rectangles that we can sort of find in different ways. One is to say, all right, I have a rectangle up here and a rectangle down here. If I find the area of both of those and add them together, that will work. I have both sets of dimensions, so I could do that. Another way to consider this is to, I'm going to try not to erase too much stuff. I'm going to lose those sides though for sure. Another way to consider it is maybe break it this way, where here you have a first rectangle, a second rectangle. Again, find the area by multiplying the length times the width and then add them together. A final way to do it, and that was sort of the original set of scribblings that you saw on here, is to consider that we actually have one entire large rectangle, which we can find the area of, and then we can subtract the area of this little square here. Now, if you do this correctly, all three of these methods should come out to the same answer. You could also actually break this into more shapes than that. You could actually, let me scooch backwards here. You can actually also, if you wanted to, I guess break it into even more little shapes. You could have 1, 2, 3 rectangles that you would multiply and then add together. Again, I'm not sure what the benefit is of doing more work or less work. Here, I guess more work's probably less good because you're more likely to make mistakes. So just for ease, I'm going to just do the one that I've got set up here already. But any of these three will work. If you have a preference, by all means follow it. I'm going to do this one here. So I'm going to find the area of what I'll call rectangle number 1 and rectangle number 2, and I'm going to expand them out to find the area, and then I'm going to add them together. So let's start with sort of a statement of intent, I guess. I don't know how much space I have. Oh, I got lots of space. So we'll say that the area is going to be equal to area number 1 plus area of rectangle number 2. So let's start by finding the area of rectangle number 1. Now again, we're looking for two sides here, and fortunately, let's see if we can pile even more color on this. It's going to be length times width. So it's going to be x plus 2y times, I think it was x minus y that was in that spot. Let's just double check. Yep, x minus y, perfect. And then we are going to add that area to the area of the second rectangle. Now the area of the second rectangle has a length and a width. So we are going to have 2x plus y multiplied by, I think that side was 2x plus 3y. The setup is a little bit painstaking. You want to make sure that you're getting all the right values in there. But from here, now we're just expanding out like before. And again, as I said earlier in this lesson, artificial brackets around there. Now in this case, we're adding, so again, it won't make too much of a big deal, but at the same time, we want to make sure that we're distributing properly. So let's follow our good protocols. All right, let's do our expansion. X times x, x squared, x times minus y, minus xy, plus 2y times x is plus 2xy, and 2y times minus y is minus 2y squared. So there's our first one. Let's do the second. Again, I want to keep the brackets in there. So we have 2x times 2x is 4x squared. 2x times 3y is plus 6xy. Y times 2x is plus 2xy. And y times 3y is plus 3y squared. Again, trying to follow my own advice, I'm going to do a rewrite step where I combine these two that are alike. Minus xy plus 2xy is plus 1xy minus 2y squared plus, and now I'm going to simplify this bracket. Plus 4x squared, so plus 6xy plus 2xy is plus 8xy, and there's our plus 3y squared. So there we go. At this point, if this were a subtraction, we would be distributing, but we're not. So let's just gather together our like terms. We have an x squared and a 4x squared. That's going to give us 5x squared. We're going to have some xy's to deal with. So we have a plus xy plus 8xy. That's plus 9xy. And last but not least, we have minus 2y squared plus 3y squared. That's plus 1y squared. And there you have it. This is a statement of the area. Again, with a little more time, I might restate that and make it a little bit fancy, but there you go. That's how we work it through. This is the last part of the last lesson in Unit 0. Hopefully this has made sense to you. Again, I stress make good copies of these notes either on the skeleton notes that are provided or in your notebook, just to make sure you have a reference when you're working through the homework. The homework is on the next couple pages, including the questions themselves, followed by on the next page the answers. So good luck with this. Any questions, reach out via email, contact me in any way that you can, and I'll see if I can provide you some assistance. Otherwise, good luck with the homework and good luck with the assessment.